Hello student, today we are going to see conservation of energy. Energy neither be created nor be destroyed. Total energy become constant. Okay. I am taken the ball is falling from some height. There are 3 points I am taken. A, B, then the point C, ground. Okay. So what is potential energy? The potential energy, it's a stored energy. Kinetic energy is a mechanical energy, like object is moving. Okay. So when the ball hits some height, okay, imagine some object at some height. If you dropped, it will go. Okay, it will fall down. That's going to be a potential energy going to convert as a kinetic energy. At a point, no. Imagine one ball at some height. Okay, some height. If you leave the ball will come down like a rubber band. If you are stretching the rubber band, no, it has potential energy. If you leave, it will come to the original position. Potential energy going to convert as a kinetic energy. At a point, the potential energy is maximum. Okay. Then imagine at a point 500 joule as a potential energy. When it comes to the B will imagine exactly half of the position. 500 joule going to convert as a 250 as a potential energy, 250 as a kinetic energy, remaining 250 as a potential energy. Okay, so when it comes here, kinetic energy half, potential energy half. Okay, 500 no, 250 already converted, 250 going to convert when it is exactly off the position. Okay, at ground no, there is no potential energy, fully converted as a kinetic energy, 500 joules as a kinetic energy. Okay, I hope you can understand. At A, potential energy is maximum. Okay, when the object is dropped at some height, when it's come exactly at center, this much is already converted, this much is going to converted. Okay, so kinetic energy is going to be 250, potential energy is going to be 250, exactly off of. Okay, when it comes to the ground, potential energy fully converted as a kinetic energy. So here kinetic energy maximum, potential energy is equal to 0. That only we are going to do. Okay, it's a very simple concept. Wherever you are calculated, the total energy remains 500 joules. Okay, 500 joules. Here also 500 joules, here also 500 joules. But here potential energy maximum, here kinetic energy maximum. Here both will be sharing off. Okay. Now first we'll take it the ball at A point. Okay, maximum point. So maximum at some height we are taken. Okay. What is the potential energy? Potential energy formula mgh. Okay, at the A point, potential energy, maximum potential energy. So maximum potential energy mgh, potential energy formula. At A point there is no kinetic energy. Kinetic energy become as a 0. I am talking about maximum point. Total energy is equal to kinetic energy plus potential energy. Kinetic energy plus potential energy. What is kinetic energy? 0. What is potential energy? mgh. What about total energy? mgh. Example, like a 500 joules. Okay, next I am going to take it at the point of B, in between, center. Okay, exactly at center. Okay, exactly at center I am taken. Okay, this is ground, this is B point, this is A point. Okay, now ball at B point, exactly center. So kinetic energy of potential energy of kinetic energy mgh by 2. Maximum mgh by 2 is a kinetic energy, potential energy mgh by 2. Of. Why sir of? Because this much already converted potential energy to the kinetic energy. Potential energy to kinetic energy already off converted. This much potential energy stored on the object. Okay. So this going to convert, this going to convert. Okay, this is potential energy going to convert as a potential energy mgh by 2. Already converted as a kinetic energy mgh by 2. At B point, both going to share it off. Okay, B point, one more thing also is that in between somewhere, we are taken exactly off. In between somewhere means how to do the equation. That I will do separately. Okay, now total energy is equal to potential energy plus kinetic energy. How much potential energy? mgh by 2. How much kinetic energy? mgh by 2. Off. So total energy of will get mgh. Same 500 only will get, 500 joules only will get, but 250 as a kinetic energy, 250 as a potential energy. 250 going to convert, 250 already converted. Now we'll take it at the ground. Ground, there is no stored energy. So we'll get as at C point ground maximum kinetic energy. What about potential energy? Potential energy is equal to 0. Now total energy is equal to kinetic energy plus potential energy. Okay, kinetic energy mgh, potential energy 0. Okay, maximum kinetic energy, total energy will be mgh. Okay, now we'll do the graph. Okay, so same point, same equation I am taken like this: a b c. A, what about potential energy? Maximum. B, exactly off. Okay, C, no, it is 0 potential energy. It is the potential energy. Now what about kinetic energy? A, minimum kinetic energy, B, off, C will be maximum. Okay, this is going to be a kinetic energy and this is going to be a potential energy. Total energy remains constant, neither we create nor we destroy. Total energy remains constant. This is a graph of the conservation of the energy. Okay, next one. At B point, we have to do one more also. Exactly off means potential energy off, kinetic energy off. In between somewhere. The object in between somewhere. We'll take it here. Okay, A position, B position, C position. At B, no, in between somewhere. Okay. This is a height, acha height. Okay, this is a x distance already converted. H minus x distance going to convert. H minus x distance going to convert. At B, total energy is equal to potential energy plus kinetic energy. What is potential energy? Potential energy this much. So potential energy this much. M G. That height is h minus x. That height is h minus x. What about kinetic energy? Already converted. This much mgx plus mgx. Okay, so mgh minus mgx. I am taken this as a inside plus mgx. Mgx get cancel. Mgh. Okay, this is a total energy at the point of B. It in between somewhere. Okay. So now the next thing, you can ask me one more question also. Sir, kinetic energy is equal to half mv square. Why you are using as a mgh? That's going to represent with the work energy theorem. That's going to represent with the work energy theorem. What is the work energy theorem? So mgh we are going to prove as half mv square. Okay, work done is equal to mgh. Mgh is equal to half mv square. This two we are proving no. Potential energy is equal to kinetic energy. That formula if you prove, you can use it. Okay. So first thing, work done is equal to Fs cos theta. Okay, we'll take it, the object is dropped at some height. Mg acting downwards, that's called force acting downwards. Displacement also downwards. Angle will be 0 degree. So mg displacement h, angle will be 0 degree. Cos 0 will be 1. So potential energy, it's going to be mgh. Okay. Now we are going to prove work done is equal to Fs cos theta. No, that is equal to mgh. So now mgh is equal to half mv square. That only we are going to prove. Okay. So imagine one object is thrown at some velocity. It's going to finally become as a rest. U will be 0, V will be something. Okay. I used equation of motion. V square is equal to U square plus 2AS. So this is 0. V square 2GH. So H is equal to V square by 2G. H is equal to V square by 2G. So mg H is equal to V square by 2G. So G get cancelled of mv square. Both we proved. If you want, you can use it as a potential energy, as a kinetic energy. Okay. Thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.